Hello everyone. In this video we're going to be explaining and demonstrating how you can migrate your virtual machines running on VMware to virtual machines running inside a Kubernetes cluster. And this includes the applications run inside those VMs. If you are watching this, you are likely aware of the recent VMware license price rises. And maybe you've already decided to move away, or maybe you're still weighing up your options. Regardless of your position, it's important to recognize that the opportunity is not just to escape vendor lock-in. This is also a fantastic opportunity to modernize your applications while solving an urgent problem. This video will focus on the migration away from VMware, removing the immediate business license issue. Our modernization video, linked below, will explore more options that can be taken post-migration. To make sure we're all on the same page, I'll start by outlining the context. In November 2023, Broadcom purchased VMware for over $60 billion and then proceeded to change VMware's licensing model the following month. This change in the model has significantly increased price for their customers. Some have even quoted a rise of over 1000%. Faced with this change, VMware customers can either choose to accept both the current and likely future price increases by staying with VMware, or they can start to migrate away. There is research out there suggesting that more than half of VMware customers are leaning towards the second option, moving away. But what options are available to those looking to make this transition? There are three general available options. Option 1 is migrating your infrastructure to a public cloud solution. Option 2 is switching to another closed source solution. And option 3 is migrating to an open source solution. We are going to be going into detail about option 3 and demonstrating a migration to an open source solution, KVM, on Kubernetes. Because if you want to modernize your application by converting it to a cloud native architecture, the de facto method is to have a Kubernetes cluster. But what is KVM? KVM is short for kernel-based virtual machine, and it functions as a hypervisor for Linux machines. It is a well-established open source virtualization solution that was released as part of the 2.6.20 kernel in February 2007. An important note about KVM is that it requires hardware virtualization extensions, but nowadays almost all modern Linux machines support virtualization with KVM. So a Kubernetes cluster with modern Linux nodes can utilize KVM. But Kubernetes is a container orchestrator and containers aren't virtual machines. So in September 2019, KubeVirt was accepted by the Cloud Native Computing Foundation. And this open source project enables the running and managing of VMs in Kubernetes clusters. If we take a look at a stack diagram of a VM on VMware and compare it with a VM running in Kubernetes, on VMware, our virtualization platform is vSphere, and in the new stack, Kubernetes and KubeVirt replaces that platform. As for the hypervisor, ESXi is replaced by a QEMU and KVM hypervisor. With the new stack, when you declare to Kubernetes that you wish to deploy a VM, there will be a Kubernetes pod with a virt launcher responsible for interacting with libvirt, which will instruct QEMU to create the VM, and QEMU will delegate the CPU virtualization to KVM. Now let's discuss how we can prepare for a migration. I'll start off by saying that every environment is unique, so I won't be able to give an exhaustive list of all preparation actions that applies to everyone, but I can highlight a few steps. First of all, you shouldn't migrate your entire VMware infrastructure at once. Start off with a single application. You want to first verify the migration process and to get experience with it. So select one application that is deployed in a VM or across multiple VMs that you want to migrate. For our demo, we'll be migrating an application made up of multiple front-end and back-end services. But you don't have to select an application that is similar to this. We recommend you select an application that will give you the most information as you perform the migration for the first time. For example, it could be a critical application where if your team is able to migrate it successfully, you know that your team will have the confidence to migrate all other applications. Whichever application you select, you must prepare the application, its infrastructure, and your teams for any potential downtime or disaster recovery. So once you've selected an application, you will need to prepare its VMs for the migration. Our demo application is deployed across two virtual machines, one to host the front-end services and the other to host the back-end services. We need to ensure these two VMs are ready for the migration. One thing you will need to do if you want to perform a warm migration is to enable the changed block tracking feature for the VM and each of its virtual disk. To verify whether or not this is enabled, check the properties of your VM and look for CTK enabled. In the screenshot, you see we have change block tracking enabled for a VM and its single hard disk. If a VM has multiple disks, then you have to set CTK enabled for each one. Also, for each VM, make sure the core's pure socket is not smaller than the number of virtual CPUs. Now on to the Kubernetes cluster. We will need a Kubernetes cluster that has nodes that support KVM, has Kubevirt installed, has Kubevirt CDI installed. It is usually a separate installation and it is required to enable importing the data from VMware onto your Kubernetes cluster. Your cluster must also have a storage class that will meet the requirements for the VMs that will be migrated onto your cluster. And once your cluster is set up, you'll want to verify that Kubevirt and CDI is working by running a VM using a publicly available ISO image. You must also ensure your migration tool can communicate with your source vSphere environment and your target Kubernetes cluster environment. If your migration tool was deployed in the Kubernetes cluster, then ensure that pods within your Kubernetes cluster can communicate with your VMware infrastructure. Once you've finished preparing your application, your VMs, and your network, you can begin the process of configuring a migration tool to find the VMs of VMware and migrate them onto our target Kubernetes cluster. We understand that this migration can be tricky, which is why we have a pilot program where we work with your organization to understand your wider requirements before we begin. And rest assured, this is an end-to-end pilot where we work with your teams pre-migration, during the migration, and post-migration. Let's go over the warm migration process that we will be demonstrating. Amongst the 7 R's of cloud migration, we will be demonstrating a rehost, lift and shift strategy. We start off with our VMs on vCenter. Then, we need to gather the MoRefs for our VMs and their associated data store and network. We then pass these references to our migration tool so we can find them, and we also tell our tool what the Kubernetes equivalent is for each resource. When our migration is started, our virtual machine's data is copied into our Kubernetes cluster. Once the disks are in place in our cluster, the VM is turned off, so a cutover can be performed that will complete the data copy using the delta. After the data migration is complete, we have an image accessible in our cluster, but this image needs to be converted into an image that is compatible with KVM. Once this image has been converted, Kubevirt uses the image to spin up a VM inside our Kubernetes cluster. At this stage, the VM migration is complete. However, the application which was also migrated is now running inside a new environment. So post-migration steps are required for our application. An example of one of the post-migration steps is to apply new network configurations for our application within the Kubernetes cluster. Our modernization video, linked below, will explore more options that can be taken post-migration. To carry out this migration, we have chosen to use a tool called Forklift, which is an open source tool that facilitates migrating virtual machines to Kubevirt. However, we have used a forked version of Forklift. For migrating virtual machines in VMware, it uses several different tools, which include libguestfs, nbdkit, Kubevirt, Kubevirt's containerized data importer, and virt-v2v. If we were to put these tools into the context of a warm migration, when the data migration occurs, while the VM is still turned on, an initial snapshot is taken on VMware, and the virtual disk is copied using the nbdkit. And since we have changed block tracking enabled on our VM, when a second snapshot is created, the data transfer for the second snapshot will contain only the difference between this snapshot and the first initial snapshot. So snapshots are taken periodically until the cutover time. When the cutover happens, the VM is turned off. Then virt-v2v, run inside the Kubernetes pod, will convert the disk image to be compatible with KVM. Forklift allows us to facilitate migration by extending the Kubernetes API with custom resources, and it also makes use of Kubert's custom resources. So when you install Forklift in your cluster, it will also come with many different custom resources. However, the ones we'll be using on our migration are the provider, the storage map, the network map, the plan, and migration. And we will talk about each one in more detail as we go through the migration in our demo. Similar story with Kubevirt. When we install Kubevirt, it will also come with custom resources. But the relevant ones for our migration are the data volume, the virtual machine, and the virtual machine instance. So both Forklift and Kubevirt have components deployed as Kubernetes pods inside a cluster, and they are looking for these custom resources. And if they detect that one has been created or updated, they will take action based on the configurations inside these objects. So to perform the migration, we will only be deploying Forklift custom resources, and we're going to let Forklift handle the deployment of Kubevirt custom resources and any other Kubernetes resources required for the migration. Let's start the demonstration. In vCenter, we have two VMs, a front-end VM and a back-end VM. If we go into the terminal of our front-end VM, we can see our front-end services running inside the VM. And if we go into the terminal of our back-end VM, we have our back-end services. One of them is Redis, so let's run a monitor command and try out our application. Our application is a web store, and to verify it's working, we'll purchase something from the store. After purchasing something, if we go back to our Redis monitor, we can see outputs generated by our actions in the store. We now need to grab the MoRefs for our two VMs and their associated data store and network. To collect this information, we have a script we use. And as you can see at the end of the output, we have the MoRefs we'll be putting into our Forklift custom resources. But we have two VMs, so we also need to run our script against our other VM as well. By setting these MoRefs in the appropriate Forklift custom resources, Forklift will be able to find the resources in our VMware infrastructure. But before that, Forklift will need the URL and credentials needed to access our VMware resources. So we deploy a Kubernetes secret that will store these credentials. Then we will deploy a provider object that will contain the name of the secret we just deployed and the URL Forklift will use to access our VMware resources. A second provider for the cluster Kubevirt is installed in is also deployed. With these two providers, Forklift will then be able to communicate with the source environment where our VMs are hosted and our target environment where Kubevirt is installed. When a provider is deployed, a component of Forklift will detect a new provider has been created. It will then check the credentials within this provider object and try to access it from within the context of the Kubernetes pod the forklift component resides in. If it can successfully access the environment, the status of the provider will be marked ready. Another thing to note before we move on is that forklift will need to be provided an image of a VMware Virtual Disk Development Kit, a VDDK. This is to help with transferring virtual disk from VMware. You can set this image in the vSphere provider. Now, let's move on to the storage map. This is the Kubernetes object we deploy to tell forklift what Kubernetes storage class our VMware data store should be mapped to. To create this mapping in this storage map object, we set the MOEF for our data store, and we also set our Kubernetes storage class. In this case, the storage class is called PXCSI replicated. Next, we have the network map. In our network map, we have set the MOEF for our VMware network and have mapped it to the Kubernetes pod network. Then we have the Kubernetes objects that represent our migration plans. A plan contains the references to all configurations needed to perform a migration. So in one of our plans, we can see here we've set the MOEF for the VM we want to migrate, but we are also required to provide the names of the providers, the storage map, and the network map configurations that will also be used as part of the migration. When a plan is marked as ready, we can execute a migration by deploying a migration object. So let's start the migration for our backend VM. Once we've deployed the migration object, we can see its status and the status of the plan indicating that a migration is currently happening. If we want to describe our migration object, you can see in the spec that we reference the plan that is to be executed. Since the migration just started, we should expect a data migration to be happening, meaning a data volume and a PVC associated with it will be created in our Kubernetes cluster. Here, we can see two data volumes have been created, one for each disk the VM has. The frontend VM only has one disk, so only one data volume is created when that VM is being migrated. Looking at the progress column, we can see that the data transfer progress has been completed for one data volume but not the other. We can also see that there is an importer prime pod which is created by the Kubevirt CDI and is responsible for the data transfer. We can run a watch command to see the progress of our data volume change over time, and we can also follow the logs of the pod to see what it is doing. As we wait for the data volumes to be imported, if we check the vCenter UI, you can see that a snapshot has been created. Once all the data volumes are at 100%, they are paused until the cutover time. If you didn't set the cutover time in the migration object beforehand, then you can manually add the cutover time at this stage. For example, when migrating our frontend VM, we use the kubectl patch command to add in the cutover time. However, when migrating our backend VM, we set the cutover time beforehand, so the cutover happens automatically. The VM is powered off when a cutover happens, so if we check the vCenter UI, we can see that the snapshot is now gone, and we can also see the backend VM is powered off. Now, forklift should deploy virt-v2v to convert image to be compatible with KVM. Let's take a look at the logs of this pod. In the logs, we can see it mentions libguestfs, mbdkit, and other tools. It's important to mention that the virt-v2v container will need elevated permissions to carry out its task. These security configurations can be set in the pod's manifest. However, security settings in the node the pod is running in can block those permissions. So if the virt-v2 container does not have the right permissions, the migration will fail at this conversion step. If there are permission issues, examples of error messages outputted by virt-v2v include couldn't create user namespace, operation not permitted, failed to detach isolated namespaces, operation not permitted, failed to remount, permission denied. If you are attempting this and believe that permissions set on the pod level are correct, but the virt-v2v process is still failing, you may have to update the security settings on the node level. If the permissions of the node and the virt-v2v container are correct, then once virt-v2v has done its job to convert the image, the migration of the VMs from VMware to Kubevirt in our cluster is completed. If we check the status of our migration and plan, both are marked as succeeded. And since the migration has succeeded, that means we now have VMs running in our Kubernetes cluster. If we successfully performed the migration against both VMs, then we should have 2 VMs running in our cluster. These VMs represent our Kubevirt virtual machines. If we check the spec of one of them, you can see the PVCs tied to our data volumes are set as volumes, and we can also check the spec of our VM. With both VMs migrated onto our Kubernetes cluster, we now have our application running inside a new environment, but we need to verify the application is working and make sure it's accessible. To do this, we need to deploy Kubernetes services that will direct traffic to the services that make up our application. So we have created a manifest for each Kubernetes service we need for our application. You can see each Kubernetes service has a selector config in it that it will use to find the Kubernetes pods the service will be directing traffic to as a load balancer. To deploy these Kubernetes services, we use the kubectl apply command. And with the Kubernetes services deployed, we can now use a port forward command so we can access the application using localhost. With the command running successfully, we can access the application again, but this time it is running inside virtual machines inside a Kubernetes cluster. We can verify it's working inside a cluster by using the same method we used last time, which is to purchase something. Since we can see our application is working, our next post-migration step would be to expose it to traffic from outside the cluster. However, this concludes this warm migration demo. As mentioned previously, we have a migration pilot program where we work with your organization to understand your wider requirements and guide you through an end-to-end migration for one of your applications. If you're interested in learning more, a contact form will be linked on screen. Fill it in and we can put you in touch with a member of our team for a chat. That concludes this video. By following these steps, you can successfully negate the VMware license risk and move your VMs into a Kubernetes cluster. If you're looking for the next logical steps after this migration, check out our modernization video, which goes into detail about the options available to fully leverage the benefits of Kubernetes. Thank you for watching and goodbye.